Afternoon, everybody. Wow, so lame. Let's try it again. Good afternoon, everybody. Yeah, this side of the room. Yeah, that side of the room. Yeah. All right. How was the box lunch today? Yeah, it's good. Yeah? All right, cool. So, welcome to Case Then Explained. My name is Mark Russinovich. I'm CTO of Azure, but also I'm CTO of sysinternals. How many people have heard of sysinternals? Just good. Anybody never heard of it before today? All right, you're excused. Yeah. So, and how many people have been to one of these sessions before? Raise your hands. Okay, I'm sorry, because this is all the same content as last time, so you're all going to have to leave. No, I'm just kidding. This is all, for those of you that have been to this session before, and maybe even multiple times, you know that every time, this is a bunch of different cases. Some of the techniques are the same, but every single case is one that I've either gotten from somebody that solved a problem in the real world, or I've solved myself, and demonstrates some of the use of the sysinternals tools and some of the troubleshooting techniques that are possible with the sysinternals tools. This is the agenda for the session. I'm going to start with just an introduction, kind of tell you why troubleshooting still matters, because if you haven't realized that it still does. And then I'm going to go through some examples that are categorized by the symptoms they exhibit. Sluggish performance, errors, malware, and then we'll conclude, of course, with a look at blue screen crashes. Now, the reason that troubleshooting still matters, how many people have, well, I mean, I'd let you answer. How many people have experienced a problem on your computer in the last day? In the last hour? Because if you, anybody right now that we can troubleshoot for you? So the reason that we run into these problems is that software developers are focused on writing code for the scenarios they want to solve, and they design their code to work under certain expected conditions. They don't have time to go test their software under all the bizarre conditions that show up in the real world, on a real person system, with administrators that are being aggressive with locking down security policies, with other software that comes along and interferes, with software that's been uninstalled that has left stuff behind that is interfering with some other new software that's on the system. That software file might be locked because another piece of software has got it in use, while another piece of code tries to access it and can't. All of these things cause the code to end up going down paths the developers never anticipated. And what happens with that code is that it ends up sometimes not even checking for the results of the operations it's performing, so there's no error message thrown up, and it'll fall down a different piece of code where it tries another operation that does fail, and what you end up getting at that point is an error dialog box that has nothing to do with the root cause, completely misleading you as to what really caused the ultimate problem. Or the code ends up treating a buffer as if it's got valid data in it when it's got garbage in it, and it might end up in an infinite loop at that point, hanging your CPU and causing the app to go unresponsive. Or, of course, if it's got garbage buffer data in a buffer, it might reference it as if it's a valid memory pointer and then end up crashing. So all of these things are the results of these programs hitting unexpected events. Sometimes some of the dialog boxes we see when software runs into these things are kind of humorous, like this one. This is my all-time favorite because, well, it's from Microsoft, so I can make fun of it. It's unknown error, which is extremely useful, but then the dialog box has the audacity to ask you if the information was useful. There should be like machine learning to say, send him useful error analysis to say this thing is not useful, let's not ask the user if it's useful. Here's another one that's kind of fun. This is Visual Studio. And this one is actually one that still is in the Visual Studio code, so I've seen this more recently on more recent versions of Visual Studio, a zombie process. So process is in a zombie state, so this is like rise of the processes kind of thing that Visual Studio is dealing with. This one's extremely frightening. Catastrophic failure, like the world is ending because we can't copy this file or folder, but we want you to tell us it's okay. And then there's the we just give up on error messages. Or just try to be funny. But so those are some, and by the way, this one I showed up on Twitter about a year ago. This one's really funny because this is what the average person, how they read one of the dialog boxes that developers throw up, which is something happened, you have to click OK just to get on with it. You can see some technical crap. You can see more technical crap. You can launch photon torpedoes. I mean, it's all just garbage language for them, but that's what the average person interprets it as. So the purpose of this talk, of course, is to show you how to look underneath the hood of what's going on so you can troubleshoot and diagnose these problems and get to a root cause. Now, one of the fallacies of troubleshooting, people that look at it say, hey, there's a recipe that you can follow. Particular problem, step A, step 1, step 2, step 3, answer. And that's not the case. Troubleshooting is still as much of an art as it was 10 years ago, 20 years ago. You have to practice it to get good at it because every case looks slightly different. And you've got to practice it to know what signs to look for when you're troubleshooting a case and do pattern matching. Oh, I saw this before at one point was because of a locked file. Let me go back and see if there's a sharing violation on something. Or I've looked at enough traces to understand the way Windows processes operate, what it looks like when a process starts up, what it looks like when a process shuts down. And now I can go and use that information to help myself troubleshooting. The tools I'm going to show you let you look at file system, registry, file system, DLL, process thread, even networking activity. And all of these types of activity can help you understand what led up to an ultimate problem that you experienced. The techniques and tools are applicable to lots of different scenarios. Of course, I'm going to be showing you the sysinternals tools. And speaking of sysinternals, I just want to point out, because I get asked this a lot, Mark, do you still work on the sysinternals tools? And I still do. In fact, I just posted just a couple weeks ago a number of updates to some tools, including Process Monitor, Auto Runs, which you're going to see today. Another tool, Sysmon, which is one of the newest tools. I posted an update too. I work on these tools myself, and then there's also some other people that now that are helping me. Bryce Cogswell, the co-founder of sysinternals, retired from Microsoft a long time ago. He no longer works on them at all. He is basically at home in his bathrobe all day, I think, which is fine. You know, I fine way to spend your life instead of sysinternals tools. I can't believe he doesn't want to work on sysinternals tools. But I do have some other people now that are contributing to the tools. So Sysmon, for example, has another 2 or 3 people that have contributed stuff to the tools. So let's get started now on the tools. Oh, one thing I want to mention before I get started on the tools is to talk about something that Aaron and Margosas and I just released in the fall of last year. This is the second edition of a Troubleshooting with the Sysinternals Tools book. The first one was called Windows Sysinternals Administrator's Reference. We thought this would be a better title to capture what the book really is for. And this version has a bunch of new content. It's about 650 pages, deep chapters on the core tools, the major tools. Every single tool in the suite, all 70 or so, is covered in the book. There's a whole section on troubleshooting cases, including many cases that look similar to the ones I'll be showing you today. The other big change in this version of the book is that if you saw the previous version, Aaron's name was very small compared to my name. Now Aaron's name is the same size as mine, which slipped through the copy edit pass. I don't know, I missed that. But then I thought about it and I thought, okay, I'm not going to go ask them to reprint the book because actually Aaron wrote almost all the text. So I thought maybe his name deserves as big a spot as mine. But don't tell him I said that. I have him give me all his royalties just because his name now is as big as mine. So that's the book. How many people got the book, by the way? Just raise your hands. So a few of you. I'll be doing a book signing at 4 with Aaron on that book, by the way. Okay, sluggish performance. How many people have experienced a sluggish computer that wasn't running Vista? Okay. Come on. So all of us have, and we still have these problems today. This particular case was sent to me by somebody that after an upgrade to Windows 10 across the enterprise, all the users began to complain about slow system logons. And after about 10 days, their machines would become completely unusable. If they rebooted them, the systems would run smoothly again. But after another 10 or so days, the systems would slow down to a grinding halt, and the users would all be calling the help desk, and rebooting would fix. So at some point, the administrator said, I need to dig into this and figure out what the root cause is. Has anybody seen a scenario like this where systems degrade, like not just the old Windows degrades over time thing, but really after 10 days it becomes unusable? People have seen this? So maybe you experienced this exact problem. The administrator got onto one of the boxes, and the first tool they used to try to figure out what was going on was a tool called Process Explorer. How many people have used Process Explorer? How many people still use Task Manager? So some of you still use Task Manager, and you probably use it because there's some feature in it that Process Explorer doesn't have. that it will get at some point. Some of you just use it because you just don't know any better yet. But Process Explorer, a lot of people consider Super Task Manager. Let's take a look at Process Explorer, a quick tour for those of you not familiar with it. I've just opened it up. It was sitting there with an icon in the tray, and one of the things that I always do is configure Process Explorer to run whenever I log onto the machine. And you can do that by going to the options and saying, run at logon. If you're running it elevated, which I recommend you do, meaning with admin rights, so log in, launch Process Explorer elevated, and then say run at logon. Every time you log on, it will run elevated because it creates a scheduled task that runs elevated, so you don't need to elevate it after you've launched it. The first thing you'll notice that's different than Task Manager is that it's got this tree of processes, which reflects the parent-child relationship. A process like WinLogon creates these child processes, font driver, logon UI, and DWM. The other difference is that there's a lot of color coding. The blue processes represent a certain type of process. Anybody know what those are? They're what? Boy processes? No. It's a good guess. They're processes that ran in my security context. So when I logged in, any process that runs as me is a blue process, or you is a blue process. Now there's these other processes up here that are pink, and no, they're not girl processes. These are processes that host Windows services. Some of them are designed specifically for a Windows service, and so those are the ones with names like lsas.exe, searchindexer.exe, obviously the search index process. Service hosts are designed to host a DLL that implements a Windows service. And some of these service hosts will host more than one. And this is where tooltips become interesting in Process Explorer, because for these hosting processes, if you hover the tooltip over them, you will see what's hosted inside them. For example, this service host is running the Extensible Authentication Protocol service. If you look in the Service Control Manager or the registry, you will see EAP host as the service control entry for that service. And then you can see also the way it was started up by looking at the command line, where the command line here is -k net services -s EAP host. So those are the things that you can see with the tooltip. The other things you see here are the description, the company name. These come from the primary executable image. So for service host, all you see is the generic host process for Windows services. It's from Microsoft. If you double click on one of these, that's when you get taken to the detailed information about a process. This is host process. Here's the same information we saw on the display. Here's the version number. Here's when it was built, the path, the command line, the current directory. Auto start location we'll come back to later. You see the parent process. So this was a child of the services.exe process, which is the service control manager. It is responsible for launching all processes that host Windows services. Then the user account, when it was started, and some other information about what kind of security mitigations it's got configured in it. The next tab is the Performance tab, and there's a bunch of CPU, I/O, virtual memory, physical memory, handle information. The Performance graph, the disk and network, usage, cutting deltas of send and receive, GPU, process isn't using the GPU. Here's the Services tab, and here's where you can see detailed information about the service. So I can't open that because I've got access denied, but I could stop and restart it if I've got access. A Threads tab shows me the running threads in that process, including its start address. And I can also look at the stacks, TCP/IP endpoints open, the security token, the environment variables that it's running with, which sometimes paths and other configuration variables can cause problems if they're misset. Job object information, so this is designed to run in a constrained way, so that, for example, if the process dies, then it might get restarted, and then the strings that are in the process. So those are a quick look at the basic features of Process Explorer. It's got a bunch of other ones, like the fact that you can look at system information by clicking on one of those mini graphs, and then you can see, if you hover the mouse, the process that was consuming the most CPU at some particular point in time. And you can see as I hover the mouse over this that it's DWM.exe consuming a lot of CPU. That is the desktop window manager, and it's doing that desktop composition as I'm zoomed in. So it's using the GPU and CPU to do this magnification that I've got, which is why we're seeing this spike in CPU usage as I'm zoomed in right there on that part of the graph. Memory statistics, summary information, summary graphs, I/O, and GPU. Now, we're going to see some other features as we go along, but that's the basic tour. Now, what this person was attempting to do was figure out why this process was consuming a lot of CPU. And there's a bunch of different things you look at, of course. You can see the CPU usage, you can see the threads. None of that information really revealed what might be causing the slowdown of the system. Well, actually, the process that he saw consuming the CPU you can see right here. Anybody recognize that? I'm not going to call out this vendor, but let's just say that they're an antivirus company and they used to be owned by Intel, but I'm not going to say anything else about them. Now, this particular person looked at that process in some detail, and there's a display shown there that in that screenshot that I haven't shown you yet, and that's what's called the lower pane view of Process Explorer. This will show you information about the internals of the process. There's two modes to that view. One of them is the DLL view, and you can get to this either by typing a keyboard shortcut or by using these toolbar icons. This shows us the DLLs loaded into that process and the files mapped into that process. And then the other view is the handle view. It shows us the open kernel resources that this process has active. This handle view is particularly useful in cases where you're trying to figure out why something appears to be locked. So let me go to this directory right here. And there's this directory here, right there. Can't delete me. And if I try to do a delete, I get this dialog box, which says, we can't delete it, something's got it in use. And so the big question, of course, is what has that in use? Can I go make it stop using it so I can delete it? Trying again won't work, obviously. So in Process Explorer, what you can do is just go to the search dialog and say, can't del, any substring match will do. This is going to scan through the handle tables and the DLLs of all the processes on the system looking for matches to what we entered. And it found a match here. There's a command.exe that's got that file open, and if I click on that, it takes me right to the handle view for that process. And there's the command.exe. Here's the can't delete me handle that's open. That command prompt is actually open over here. And the reason that directory is open is because it's got its current directory mapped to that. So there's multiple ways I could actually release that. I could terminate it here, I could exit it, I could actually even close this handle, which is kind of an interesting and scary way to do this, because, well, okay, so it actually responded fine to that. Many times, deleting a handle out from underneath the process can cause problems, including system corruption. So you don't want to do that ever, especially if you're doing it to presentation. All right, so what this person did in this case is they looked at the handle view, and you can see that this process had a lot of handles open to the same exact resource. Very clear sign that this is what's called a handle leak. The process was opening these objects and then not closing them. And over time, this consistent with the behavior they saw is over time, the system comes to a grinding halt as the number of handles open on the system goes up into the hundreds of thousands. So what they did is they went to the web and did a search and came across this knowledge base article, high CPU usage called by the endpoint security firewall due to a handle leak, and then describes how you can go down, get the patch for this. So this user, with the help of Process Explorer, was able to figure out handle leak, looks like handle leak in this process from this vendor, go to the web, search the vendor's website for a handle leak, and then come across this and solve the problem. So a few steps that would have been impossible without this kind of insight into the process. A high CPU usage, nailed down to a handle leak of a particular type of handle. This next case is one that somebody sent me. They were running a hex editor. It's called HXD. It's actually one that I use too. It's a really cool, simple little hex editor. You can open files and see the hexadecimal contents of the file. Whenever they'd launch it, it would take a long time to start. So of course they open Process Explorer, they look and see that it's consuming a lot of CPU during its startup, during that time lag. I've recreated that process on this system. So I just launched Hex Editor, and you can see that its window still hasn't appeared, and there it goes. So that was about a 5-second lag on this thing starting up, which is kind of annoying. In fact, their lag was even longer than this. So the tool they turned to at this point, after they saw that CPU consumption in Process Explorer, and they drilled in, looked at the threads, didn't see anything interesting, was Process Monitor. How many people have used Process Monitor? So quite a few of you. Those of you that haven't, Process Monitor is a real-time tracing tool that will show you file system, registry, process, network, and DLL activity. I'm going to fire it up here so we can take a look at it in action. Now, it spews out a lot of information. These columns are the default configured columns, but you can add and remove these columns if you want and add other ones. There's a sequence number, the timestamp, the name of the process, and there's a tooltip here that will show you some information just like you see in Process Explorer. The process ID, the operation, so this is a TCP send to this, from this source IP address to that target IP address, the result of the operation, its error code if it has one, and then details related to that. So that was a 229-byte send. And then there's the start time and end time of that send operation. For registry and file system operations, you'll see a lot more information. Like here you see a query of a registry value, and what came back was 0. It's a 4-byte 0 value came back from that. So lots of detailed information. When you double-click on one of these, you can see all the information that's been captured for a particular event. The thread ID, which will become very useful in a troubleshooting case in a few minutes. The class, and I'll explain what class means in a second. And then the path, the result, and the duration. So you can see from the start of the operation to the end, this thing took that amount of time. And then here's the detailed column. The other thing you can see is the process information. This looks a lot like what you saw in Process Explorer. So you can see the path, the version, the parent process ID, the architecture, user account, and the loaded list of modules. This looks like the DLL view in Process Explorer, except this shows you the DLLs that are loaded in the process at that particular point in time for this operation. If there was a DLL load in the next operation, you wouldn't see that DLL in this view, but you would see it in the operations subsequent to that DLL load if you looked at the process tab. And then finally, the stack. The stack will show you what functions were executed down to that particular operation. Process Explorer has a ton of other features, and I'm going to highlight just a few of them as we go through. But one of the keys to Process Explorer or Process Monitor being able to use it effectively is knowing how to filter. Because you can see that just in the time we've been talking here through it, there's over 750,000 events that have been collected. Which means if you're looking for that one event that is the root cause event, it's like a needle in a haystack unless you figure out how to narrow down the view to just the events that are relevant. And there's a few different ways to filter depending on what you're trying to get rid of or include. One of them is these quick filters. If you right-click on a column and a value in that column, you can easily include that, exclude it, highlight it, copy it to the clipboard, or open the edit dialog box. I'll show you that in a second. You can exclude events before, like we don't see anything before that event. We can start to filter, and that will take a few seconds, so let's just truncate that. You can include events after. And then for any property of that event, you can use these quick includes right here. So I want to just include things with that process name, which is taskhost.w.exe, and now I've just created a filter for that. If you ever want to undo a filter, just do Control-R, and that will reset all the filters to their defaults. So that's one way, is these quick filters. Another way is to use that edit dialog box, and you can get to it by going here or by clicking on the toolbar. And here's the edit dialog box where you can take any of the attributes, use these conditions, is not, contains, excludes, select the value, and for some things like process name, it'll pre-populate with the process names that it sees in the trace, and then set an include or an exclude filter, where exclude overrides include. And then finally, the other way to do filters, if you're interested in looking for a particular process, but one way to conveniently get it is to look at this process tree. It looks a lot like the process tree in Process Explorer, except it shows you all the processes that have existed during the trace. Watch, I'll show you how you can see short-run things. I'm just resetting here. So if I type something that runs very quickly, like ipconfig, that might not even show up in Process Explorer. So it might not even show up as a process that came and went, because if it ran between refreshes of Process Explorer, it's basically invisible. But in Process Monitor, it will always show up. So if we scroll down, we will see ipconfig right there. And I can say, go to event, and now we can set a filter just for ipconfig, and we can see exactly what it did. So that's a quick look at filtering. Now let's get back to this case that I was introducing Process Monitor with, and that was this case where, oh, by the way, when Dave Solomon, my co-author on Windows Internals, he and I would get together and we'd teach troubleshooting as part of the Windows Internals class, he came up with this saying, when in doubt, run Process Monitor. He came up with that saying because almost every case, whether it had something that looked like you could catch what was going on with tracing or not, Process Monitor would often lead to the answer. So he would always just say, when in doubt, run Process Monitor. And we used to say that all the time. When my daughter came home from school with homework and she couldn't solve it, I would say, when in doubt, run Process Monitor. And then she would give me a blank look and walk away. But what we've come up with is a new expression right here. It's keep calm and run Procmon. So, because that's the meme from 4 years ago, and we still think it's cool. So let's all say that together, because that's the one thing I want you to take away from this session. Okay, ready? 1, 2, 3. Keep calm and run Procmon. It's pretty good. We'll do it one more time at the end. Maybe you'll mean it then. All right, so let's take a look. I'm going to capture a Process Monitor trace of Hexedit starting up. And we're going to see if we can figure out what was the problem. Wait, why did it start up so fast? I wasn't supposed to do that. Oh, it was still open. That was why. OK, here we go. All right, so our filtering tricks. I'm going to reset the filter, because I had one applied, and then do the window key. This is another way to do it. I don't want to go to the filter edits. I don't want to do quick edit. I just want to say, just look at that process. Then I want to stop capturing trace, because I don't need anything else. So this is the full trace of Hexedit. We're looking for signs of a hang. There's a couple ways you can look for this. One of them is to just look through the timestamps on the left side, looking for a gap that approximates the gap that you expect to see, about 5 seconds. That can be pretty time-consuming. But that's one way that I've done it, and other people have done it, is look for these gaps. What I'm going to do, and that would work in this case. That's what this person did when they troubleshot it. But what I'm going to do is show you a different feature of Process Monitor, one that I've never really shown in a case that I explained before. And that is, there's a bunch of extra tools up here in the options dialog, in the tools dialog. Process activity, file summary. This will show you aggregate views of all the file system paths or registry paths or the processes and their CPU usage, memory usage over time. And that can be particularly useful. In this particular case, if we double click and look at this, you can see this is the over the trace of Hexedit, and you can see the CPU spike, which is what they noticed in Process Explorer here. And we see the spike starts back right about here. When you click on this graph, you get taken in the trace to that point. And what we're going to look at is what happened right before this CPU spike started. So let's take a look at right around where that took us. And we are, let me zoom out here. We are right here on 142.35. Actually, I think I went back too far. Let me do that again. Tools, process activity summary. Put it right here at the big spike. And there we go, right before that big extra spike, because it had some CPU activity while it was starting up, and then it spiked even more. Right there, the last operation, right before the CPU, was this, and you can see the gap here, 142.35 to 142.41, which is 6 seconds. The last thing it did was close this file right here. And that's what this user saw when they looked at their trace. The last thing before that gap in time that corresponded to when they saw that delay was this. And what I want to do is jump to that file. So this takes me right to that file, which is the .ini file for HexEdit. I'm going to double click it and see if there's anything interesting in here. And sure enough, this is something similar to what they saw. Thousands and thousands and thousands of mostly secretly used file entries had somehow gotten into the ini file, and HexEdit was starting up and apparently processing each one of these, causing that very long CPU spike. So what they simply did was take this, delete it. Let me close HexEdit, save this, and then run HexEdit, and voila, the problem was solved. So looking under the hood with Process Monitor, they were able to trace it down to crap that was left behind somehow or got into the ini file that was causing their system or their HexEdit to slow down. So there's a case where a monitor showed you what was going on with a sluggish performance. What looked like a CPU spike underneath the hood was related to file system activity that you could see with Process Monitor. Hence, this is one of those examples where I would look at it and go, I would look at thread activity. I wouldn't really jump to Process Monitor, especially in the case where it's not like sitting there and hammering the same file over and over again, but it's rather opened a file and then it's processing it in the background. You can see that with Process Monitor. Pretty cool, huh? All right, so let's take a look at error messages. Now this user tried to start Visual Studio. All of a sudden, Visual Studio one day would launch and open up this dialog box, this error. -215 is not a valid for property width. I've recreated this one on my machine as well. And let's see what happens. Because you're like, OK, I don't care if it's illegal width. This case, it's -1536 is not a valid for property width. OK, I don't care. But then what happens is Visual Studio just terminates. So you're kind of stuck at that point, like Visual Studio is broken. How do we fix this? How do we figure out what's going on? We use Process Monitor, Procmon. All right, so let's go look at what goes underneath the hood of that and how we can troubleshoot that. So reset the filter, clear it. And by the way, I'm using control key shortcuts, keyboard shortcuts to clear and reset the filter and restart the trace. Again, we're going to use the bullseye to set a filter. We're going to stop the trace. And now we should have everything we need to go figure out what's the problem. So what's the first thing we might try looking for? Somebody yell it out. The width? No width. Next. 1536. Bingo. There's a red. No, that's not it. That's just a hit on something else. -1536. There we go. So there's a reg query value of HKey current user, software, Microsoft Visual Studio 12, main window, and then there's some data in it, 00, -536, -824, and 1. Let's go jump to that in the registry editor. Oops. Let's try that again while I'm not interfering with it. And then main window right there. OK, there's the main window. It has those values that we just saw in Process Monitor's details view. #1 golden rule of troubleshooting, never delete. And you think that's funny. How many people have deleted something while troubleshooting and then been like, oh, great. Yeah. We've all been there. I've learned the lesson many times. Rename. Just get the thing out of the way, because you could actually be doing more damage than good. And so you always want to have a way to go back to the somewhat broken state rather than a majorly broken state if you can. So let's see what happens now. And sure enough, we cleared the problem. And so that's exactly what that user did, was use Process Monitor, jump to the key, renamed it, problem solved. Something that without a tool like Process Monitor, you're just kind of stuck. You're like reinstalling Visual Studio and hope it fixes it. And it might not actually, because that's user configuration. It might just say that's what you want your window to look like. I'm going to leave it alone. So you might be completely stuck in that case. Here's another example of error dialog box. A user was installing an internal ActiveX control, and it failed with this vague error. We are unable to complete your request. There's an issue with your system. Please reinstall your smart card software and try again. And then some support information. So the debug logs reported that it was that Microsoft-based smart card crypto provider CSP was missing. And they ran the CertUtil tool, showed it was correctly installed, however. So this was a misleading error dialog box on top of a vague error dialog box. And CertUtil supported the SafeNet key storage provider DLL was missing. So SafeNet DLL was missing. They tried to reproduce the problem in a VM, and the problem didn't occur. So this is a case where they were like, maybe I'm going to capture two traces, one in the VM, one in the failing system here, and try to look at what the difference is so I can identify, apparently, whatever this DLL that's missing might be. So let's go open those traces. And this is a pretty sophisticated troubleshooting example because the traces are so different. And so most of these kind of traces like this, where you're going to want to do side-by-side, they're roughly the same. But this VM installation was very different from this real broken system installation. And the way that they found this was kind of interesting. A lot of people send me the cases and they say, oh, look, here's the two examples where I saw the difference. This is side by side. I could show you where they drilled into and saw the difference, but I want to highlight some other ways that you can use Process Monitor to drill on something like this. And I'm going to do that by taking you first to show you where they noticed that there might be a problem. And that is at these points in the trace. Let me try to expand this a little bit. And on the left side, and this is what I was saying, that these traces look so different. On the left side, you can see ActiveX cryptographic service provider reference. On the right side, you see RSA channel. Then you see the traces kind of line up right here. Now, the next thing here is down here is this Luna cryptographic provider. And on the right side, you don't see anything similar to that. You see this roughly the same shape, but you don't see that. And so what I'm going to do is show you another capability. By the way, this is Zoom It, if you're not familiar with Zoom It. It can zoom in a lot, and that's what I'm doing to zoom in. Whoops, I'm getting crazy with Zoom It. Let me do this. I'm going to do a reg enum key, or reg query key, on anything that's under cryptographic provider's default, because that's what this thing was under. So anything that begins with that, I want to do capture a trace. So path begins with that, add. And on the right side, I'm going to do the same thing. Path begins with add. And then I only want to look at reg open keys because those are the operations right here that reference these cryptographic registry entries. And so I'm just doing these quick filters. And now the last thing I want to do is go into Tools, Count Occurrences. Count Occurrences will show me all the unique occurrences of paths or whatever other value that I'm selecting in the trace. So we see that there's 4 unique paths that match that filter that I've got. And one of them is this Luna cryptographic services. On the right side, if I go to Tools, Count Occurrences, Path, you can see there's a whole lot more. And all of these look like basic standard built-in Windows cryptographic providers. The one that's different is this one, which is Luna, which is from SafeNet, which is a reference in that dialog box, that error dialog box. So this was the clue. And when they actually went and expanded and looked a little closer, they could see that that Luna cryptographic provider, Luna cryptographic provider, here, you can see that there's a a registry query, oops, my mouse is jumping around, to a value, oh, my mouse is jumping, to a value that is got an error dialog box of type of name not found. And so this type missing is what tripped up the cryptographic code and ended up causing that dialog box to show up, because that type should always be valid. Apparently on this system, the Luna cryptographic provider was uninstalled, but not completely, leaving this behind and causing that LOB installation to fail as it was using those crypto APIs. So the solution was to delete that entire branch of the key of the registry, and the problem went away. They were able to solve the problem. So this was, again, another case, under the hood, little side-by-side, little looking for clues related to the dialog box and the PAS, and they were able to get past this particular problem with Process Monitor. This next case is one that is near and dear to me, because this is one that I actually solved myself. I ran into it myself. And there's nothing more gratifying than using my own tools to solve problems that I run into. So I kind of make up problems for myself sometimes just so I can go solve them with my tools, which is a lot of fun. I try to fool myself, which is really hard to do. In this case, though, it was a problem that Windows had thrown at me. You can see that one day I logged in, I was in a meeting, and this is one of those meetings where I logged in, I saw this, like Process Explorer is going crazy with red and green. I didn't show you the process highlighting related to processes coming and going in Process Explorer, but if you launch a process, you can see that it shows up in green, and then when you terminate it, it shows up in red. On this machine, what was happening is I would see Explorer start and then disappear, and then start and disappear. And so when I opened Process Explorer to look at what was going on, whoops, I kind of went forward a few slides. There you can see I just saw Explorer with its subchild of Explorer with where fault, which is the Windows error reporting dialog box, and then it delete, and then another set of the same exact processes launch just over and over and over and over. So my machine was completely unusable. So I was almost completely unusable. So what I did was I actually launched Process Explorer itself. I couldn't use Explorer to launch anything. So this is a handy trick. It's been useful a few times. When Explorer is out to lunch, you can still launch Task Manager by doing Control-Shift-Escape. I've got Process Explorer set to replace Task Manager, so it takes over Control-Shift-Escape. So I was able to launch Process Explorer, see that, and then do run Process Monitor from there. So while these crashes are still happening, I was able to capture a trace of what was going on. And here's what I saw. Let me actually clean these up a little bit. This case has some pretty sophisticated steps that require some knowledge of the way Windows processes behaves, like I mentioned earlier. First thing I did was open this. This is the tree view. The tree view was populated with way more processes on the system. So this is the filtered tree view. What I did was filter it just to have Explorer and where fault, which is all I was interested in when I saved the trace. So that's why that's all you see here. You can see that I captured 3 iterations of this crash restart. And the grayed processes are ones that are dead already at the time of the trace, or dead at the time that I looked at this tree view at the end of the trace. The other ones are active at the end of the trace. And what I did is I figured, hey, whatever happened or tripped up Explorer probably was near the end of the trace. So the way that I'm going to get to the end of the trace is go to this first operation of where fault, because when a process is actually dying, it itself launches Windows error reporting. So if I go there to this, I see that right here, here's the Windows error reporting process start. Right above it, Explorer is creating it. And then I looked up the trace looking for anything interesting, and I couldn't find anything interesting. And then I said, OK, maybe I'm going to try another one of those to see if I can. Maybe it's more clear. So I went to this. I can't remember which one I went to. Let's look at that one. I went to go to event. And, oh, that's at the beginning of the trace. Let me go to this one. Go to event. and I scrolled up the trace, and it looked different than the other one. Actually, let me do that one just to make sure. And they look different in that the names of the registry values, the file system key paths that they're accessing are different on all of them. And so I went and looked like a 3, and they're all different. I'm like, what the heck is this? Can't be non-deterministic because it's crashing repeatedly. It's got to be something it's looking at and crashing. So then I realized that as a process is dying like this, that's multi-threaded, it still has other threads that are doing stuff while this one thread is saying, oh, it's time to bail on this. And so what I'm probably seeing is registry and file system activity from other threads unrelated to the cause of the crash. What I want to do is scroll up the trace looking for signs of a process termination. And process termination, we're going to get to it shortly. We're going to see a lot of, let me get to another one of these first. Reset arm bearings. Process termination follows a set of steps called process rundown. And the last part of process rundown is it's going to be querying a lot of files. Query information file. It's querying these files because of a feature in Windows called prefetch. And what it wants to do is understand what DLLs were loaded into the process as the process ran, so it can go prefetch them in the next time. So one of the things it does is do this rundown of querying all the processes, all the DLLs that were in the process. And so here I can see, oh, there's the thread that is actually starting the shutdown process for this thing. But it's mixed in with every other thread. So what I want to do is add the thread column by adding a thread ID, and then setting a filter just for this. And now I'm just looking at that one thread that was dying. And now my goal is to find the last things it was doing before it started this shutdown. And we're going to see, you can see lots of rundown, lots of rundown, lots of rundown. Oh, and now we have stuff going on. Registry activity. So what kind of registry activity are we looking at? We see queries to system control, radio management, system radio state, network connections, UX manager. Interesting. What happens right before these registry calls? There's a bunch of UX manager. Oh, look. There's looks like a load of network UX broker.dll. I'm thinking maybe that has something to do with it. This DLL, dynamically loaded in, which I believe is related to that little network icon in the taskbar that lets you set your wireless configuration conveniently from there. Maybe it's something related to that. How do I make it so I can disable that, at least so I can get control of my system again? That's the next question. Most DLLs like this that are dynamically loaded in Windows are configured rather than built in as hard-coded values. So if I look back in the trace and find network UX broker.dll, network UX broker, maybe I'll find the place where that thing is configured in the registry. And sure enough here, there's a reg query value of Windows Runtime Activatable Class ID Windows Networking UX DLL path pointing at that DLL right there. So what I did is I jumped to the registry, I renamed. The second I renamed, Explorer stopped crashing. So at that point, I had control on my machine again. I'd lost the little network icon, but the machine was usable again. And so I was able to go about my business. And I still could configure the networking by going directly to the control panel to do that. But what do you do at this point? And this is a great example of I didn't fix the problem. All I did was mitigate it. In some cases, that's all you can do because you're not the person that created the problem. The vendor might not have a fix. You don't have the LOB team that has the problem handy. So you're basically like, how can I get things kind of working again as much as possible, work around this problem? That's the situation I was in. Now, I'm in Microsoft, so I can get stuff done with things like this. So I sent the networking team an email, and I said, I've got a problem. You need to fix it right away. And here's what they said to me. They said, "Of course, Mark, we'll fix that immediately for you." No, really what they said is, yeah, well, whatever, just wait for the fix. It's coming at some point. Yeah, here's the fix. You can go see that we actually know what you've ran into. So thanks for not telling us anything useful. And in a few weeks, you should get your network icon back. So you can see that I've got a tremendous amount of influence at the company. All right, so that's an example of looking at some error codes, error dialog box, looking underneath the hood of errors and figuring out what's going on. And what blows my mind is thinking how the average sysadmin that's not aware of these tools, or how the average end user, how they get about their lives when they run into these things. It's just like, oh, reinstall. Because without these kinds of tools to give you those clues to work around it or fix it, it's just completely, you're stuck. So let's switch context a little bit. I've been talking about performance problems and errors with Windows and system and Windows software. Let's switch to a different topic altogether, and that's malware. Malware, of course, has been a scourge. Everybody acts like, oh, it's out of control now, but it's been out of control for like 20 years almost. And I started talking about malware and building features into the sysinternals tools for malware at least 10 years ago, at least 15 years ago. How many of you have run into malware on a computer in your network that you might be working with at your job in the last month? So not everybody? How many people have run into malware on a computer of a friend or a family member in the last month? Okay, there's more like it. How many have run into malware on your own computer in the last month? Anybody? Anybody have malware on their computer now? Because my deal with anybody, as you know if you've seen this class before, if somebody's got malware on their computer now and would like me to fix it for them, fine, but we get to see your browser history. Yeah. Never get any takers. So this particular case started with a sysadmin where every time one of their end users launched this browser, their page would get taken over with ad pop-ups. This is a particular user who happens to be in South America. So this is one of those fake, your system's broken, you need to fix it immediately kind of dialog boxes. Really obnoxious. Question is, how do they figure out what's causing that? And the first obvious place to look is go look at Explore IE extensions and see if there's anything suspicious there. Nothing suspicious. So what they did was start to turn to some of the sysinternals tools. The first tool that I'm going to show you that they turned to was Process Explorer. Process Explorer has a bunch of general troubleshooting features, but it also has some features aimed directly at malware. One of them is integration with a website called VirusTotal. How many people have heard of VirusTotal? So those of you that haven't, this is a really cool resource. I've got it open here in IE. VirusTotal lets you upload files or look for the scan results of files that have already been scanned by their hash and have 40 to 50 antivirus engines run over it and tell you what they think of it. You might be saying, what do you need 40 or 50 for? Well, there's a lot of malware out there, and there's a lot of heuristics for detecting it, and a lot of signatures for detecting it, and different antiviruses have different information. So just because one engine says it's bad doesn't mean it's bad. Even if 10 say it's bad, doesn't mean it's really bad. This could be just false positives. So by looking at the results of 40 or 50 or 60, if you see 50 out of those 60 or 40 out of those 60 say it's bad, it's probably a bad thing. So I've integrated support for scanning tools into Process Explorer so that you can go to Options and say, VirusTotal, check virustotal.com. Now this makes me, first time I do it, say that I agree to the terms of VirusTotal. And then it adds a column, the VirusTotal column, submits the hashes of these images to VirusTotal, and then reports back the number of engines that said it was good and bad out of the total, the number that said is bad out of the total number, with a hyperlink to the VirusTotal report. It also highlights in red any that have a non-zero, like this one, or something, one antivirus engine out of the 65 that looked at this said it was malicious. Which one was it? Cylance. Anybody use Cylance in here, just out of curiosity? One person? Okay. And 2, 3, few, yeah, 4. So this one, they call it unsafe. I'm not really sure what unsafe means, but unsafe, which is obviously false positive. This is a built-in Windows RDP, clip.exe. It's the clipboard manager for RDP, signed by Microsoft, core part of Windows. So clearly a false positive. But that's, and if you just had that one antivirus engine, you would be like, okay, this thing's bad. You know, that might be the cause, and you delete it or rename it or whatever, and you break your system. Now we know that that's a false positive. 1 out of 65, almost certainly a false positive. Process Explorer, for any images that have not been scanned, you can see these unknowns. That's because nobody's uploaded it to VirusTotal. And you can submit it right from here. You know, you could go to the UX and say, you know, I want to upload this file for scanning. And a few minutes from now, you're going to see the result come back from VirusTotal after those engines have scanned it. This is the first time that VirusTotal will have seen this thing, because it's looking at hashes. And now I've given it it didn't know see a hash. And that's because this is my own copy of Zoomit that I built right on this machine, which is why nobody has uploaded it. And you can see there's a bunch of others. So that's one way, is looking for, first thing you do on a system that you believe is infected, run this, do VirusTotal, and look to see if there's anything glaringly looking at you. That's what this person did in this case, is they opened Process Explorer, and they saw this. 2 processes, children of TaskEng, which is the task scheduler engine, that show up with a significant number of unsafe or malicious reports. Enough that there's almost certainly not a false positive. So they're on to something here. And they've got funny names, too, which is also a suspicious sign. They don't have any kind of legitimate text as their name. And you can see that from the description, HQ Video Pro, codecs is a very common way to trick users into downloading crap, is you say, oh, here's some content that you want to see. You need to download this cool codec to see it. Or even legitimate codecs that get bundled with crapware from kind of legitimate share hosting sites. So the next step is to take a deeper look at this. One of the interesting things about this piece of malware is that it has a digital signature on it. How does this show you that? Well, that verified in Process Explorer tells you that. And in Process Explorer, you can ask it to verify the signatures of images. And when you do that, it'll add a column that will check the digital signatures. And then we can sort and see if anything's unsigned. And you can see that there's a bunch of things. These are all tools that I built locally that don't have, they're signed with test certs. They don't have a valid root, which is why we're getting these errors from the signature verification. Everything else is verified. And in this case, this malware was verified legitimately, which is kind of interesting. Just shows you that malware, having digital signature is very low speed bump for somebody that wants to spread malware. Next thing they did is, hey, so now I've identified some malware. How can I delete it, uninstall it? They turned to a tool called AutoRuns. AutoRuns scans your system, auto-start locations, and shows you what's registered. These auto-start locations include things that run automatically at logon, for example, on the run key, or your run policy keys, or your log-off group policy, your log-on group policy, your print drivers, your LSA cryptographic providers. If that person earlier had looked at AutoRuns, they would have seen that Luna entry in AutoRuns on the logon providers tab. You would see Office add-ins, sidebar gadgets, nobody remembers what those are probably, WMI providers, network providers, LSA providers, print monitors, you can see the list goes on and on and on. This is a ton of stuff that you've got showing up here. And what I've done is intentionally turned off the filtering. The default filtering is to not show you stuff that's signed by Microsoft. And the way that we can make sure that we don't see stuff signed by Microsoft is to say that we want to verify code signatures. We can also say check virus total, and we can also say submit unknown images. Warning about submitting unknown images, that this will just blindly upload files from your system. And if it's a corporate system, it could be files that shouldn't be visible to anybody else. These files get into VirusTotal. They're shared among the antivirus community, so they're semi-public. They're not actually public. Nobody walking off the street can see them, but nation-state hackers are probably some of the people that have access to these kinds of things, and it's leaking potentially private information, so just something to be aware of. Also, if you've been targeted with an infection, this is one of the ways attackers detect if they've been discovered on your network. Because if you upload one of these images, this is a targeted file just for your company, you upload it, and now that hash is in VirusTotal, they can go query the hash in VirusTotal, and if they see a scan, they know that you found it and have done a scan on it. So I do a rescan, and now we're going to get that VirusTotal, the hash is submitted. And that's what this person did, and the functionality is the same as what you saw. In this case, when they went to VirusTotal, or when they went to auto runs, they'd already identified this piece of malware, so they weren't actually using auto runs for the VirusTotal check. They were actually just going to auto runs to see how they could delete this scheduled task very efficiently. You can see here in the task scheduler entry for auto runs a list of multiple entries for the same files and a couple of variants on this. And so what they did was went and unchecked each one of these. Unchecked, just like msconfig, disables it, so you're not doing any permanent damage. If you need to put it back, you can put it back. So they unchecked all of these, and the problem went away. OK, we're down to our final section. So that's a look at some antivirus cleaning with SystemTurtles tools. There's one other tool that I don't have time to show you, but you should put it in your toolbox for malware scanning, and that's called SIGCheck. SIGCheck is a command line tool. I've got a slide on it here that will scan files on disk. Those options right there say don't only look at executables, only look at portable executables, which are going to be malicious exes and DLLs. The VRS says do a virus scan. If VirusTotal says it hasn't seen it, upload the image for scanning. And R says for anything that shows up with a non-zero, open a browser page to it. Actually, I'll just show you that really quick because it's kind of cool. Very efficient way to, I'm just going to point it at the Windows directory. So the only thing we should see in here are, whoops, I didn't mean to do that. The only thing we should see here are false positives. And you can see a bunch of false positives showing up. It looks like Cylance actually has a broken heuristic. I'm going to stop this because it's got multiple unsafes. And actually Sophos has, PsExec. So that's SIGCheck, something to be familiar with. All right, final section, blue screens. How many people have ever seen a blue screen? No, I'm just kidding. How many people have seen one in the last day? Anybody? One over here, two? Yeah, a few. How many in the last month? We should get. So you can see that we should probably just skip this section because Windows is very reliable now and never has this problem anymore. No, I'm just kidding. Unfortunately, we still have to do this, and it's because writing a Windows driver is hard. Also, hardware problems can cause blue screens. But what does a blue screen come from? It's when the system has run into a problem so deep in the kernel that the only safe thing to do is just stop, because continuing could risk data corruption. Or continuing is the system is screwed up in such a way that it knows continuing is just hopeless. It's just not going to make any progress. So at that point, it crashes, and it saves a dump, if it can, to the disk of the state of the system that you can go and take a look at. One of the things that I've loved to do, it's kind of a hobby, is collecting blue screens from the wild. And I'm sure some of you have seen blue screens out in the real world. If you see some, send them to me, and I add them to my collection. This isn't actually a blue screen, but this is a ATM that has the new hardware wizard on it, which is an ATM that you want to stay away from. That's what that means. And this one's an ATM that wants its password changed. This is not even a blue screen, but this is so amazing, I have to show it, because this is from the MTA in New York City. This is from about 6 months ago. Does anybody recognize what version of Windows they are still running? And yes, I think our infrastructure needs some work. And if you need a free subway ticket, just let me know. Okay, ATM running Doom. Okay. Now, I've categorized these. These are billboards, blue screens. And this, this is just like a road hazard. Everybody's going to be stopping to read the error code, and I don't know. This is from a concert, actually. This is a club in Warsaw where the blue screen took place. Now this one, this is Armin van Buuren in Atlanta. Yeah, so that's about a year ago that happened. These are in-mall blue screens, automatic repair here. This is it looks like the Microsoft store actually on campus. But building blue screens. This is a building in Russia, in Moscow. Hydro project building. Hollow blue screen. So you really want to be living in the blue screen. It's the way you. The second fanciest blue screen I've ever seen. This is at a mall, and this is kind of like art. This is like blue screen art, I'd say. I want this sculpture for my house. This is the coolest blue screen I've ever seen. This is just from about a week ago. Somebody posted this, a globe, a smart globe that blue screened. Here's at the Census Bureau at the entry. Aaron got this on one of his visits. These are kiosk blue screens. Sam's Furniture, Curtis. Global entry, not starting up. So, really kind of the same kind of service you get out of Global Entry as usual. Kiosk, Hertz, Nike, just blue screen it. Here's blue screens from pop culture. This is from, anybody recognize this screenshot? It's from the movie Deepwater Horizon. This was the cause of the drill problem, this blue screen right here. And if they'd only known how to debug that, they would have been fine. But just kidding. Here's from Tom Clancy, The Division. So this is blue screens in games now. It's made its way into games. Also, it's made its way into department stores. Here's Zara. Here's one on the street, Autobar. This is not a blue screen, but this is at the Hard Rack Cafe. And you can see that they're running PS Kill over here. It's a sysinternals tool. Which I found kind of humorous. Movie theater, the blue screen, the movie, coming to a theater near you. Planetarium. Okay, airport, billboard, bus, back of a bus, subway. This one is one of my funniest, because one of my favorites, because this one a guy in Italy sent it to me. He's like, I went to the train station, and I saw this blue screen. I said, oh, I'm going to take a picture and send it to Mark. So I went up, and I took a picture. And then a guy comes walking over me. He goes, oh, you're here about those? There's another one in the back room. Thought he was there to fix them. Then there's the upgrades. Oh, wait, there's another one I've got to show you. Here's an audio clip of one. It's really good. So Scott got this one.
The president was outrageous and illegal. This is the BBC News, BBC World Service News. Just to let you know, I'm having a bit of a problem with the software here, and I'm not sure I can continue with this news summary at the moment. Just bear with me while I see if my computer will unfreeze. Unfortunately, I'm not having any success, and my computer is not letting me bring you the rest of the news.
So proper. So here's, these aren't blue screens, but these are, back when we were saying, hey, upgrade. This is in Japan. This is One Financial Plaza. The weather report. And so that's a collection. So let's get back to where we were, blue screens. Now this particular one, I ran into myself. Every time I ran PowerPoint, my system would blue screen. And this is a great lesson in it's not an app. An app can't cause the system to crash directly. It has to be something in kernel mode, a driver or the Windows kernel itself. And so what you need to do is take a look at the crash dump file and see if there's any clues as to what caused the problem so that maybe you can mitigate it by uninstalling something or fix it by going to the vendor site and getting something new. It's as easy as downloading the debugging tools for Windows, running the Windows debugger, which looks like this, configuring it to point at the symbols for the public symbol server. And so you can just literally copy this string right here and paste it in to your symbol configuration. This points at the Microsoft public symbol server to get the symbols for the Windows images and caches them on this symbols directory locally. And now you're ready to go. The next thing you need to do is find the crash dump file. Easy formula for finding it. Look in the Windows directory. If there's a memory.dmp, open it. If there's not, go into the mini dumps directory and open the most recent one. And that's how you find the crash dump file. So that's what I did is I went to the mini dump file folder and loaded the crash dump. So I'm loading that crash dump I got when I had that PowerPoint crash. And this is downloading some symbols. One thing it's going to ask you to do, or suggest you do here, and it can't find some symbols, why it's kind of hanging here as it's going to the symbol server and looking for things, is to use this bang analyze -v. And conveniently there's a shortcut to do it. Fortunately, there's some spew here that you can just ignore about this, this type referenced that's missing. That's also causing some of this delay here. In a few seconds, what's going to come up is it's going to conclude with a suggestion about what it thinks caused the problem. And it's using automated crash dump analysis techniques to do that. What I always do is always click on that bang analyze -v. And I always click on the bang analyze -v because at that point you can see the stack of the crash. And the stack can give you insight into why the analysis engine concluded what it did. It can also sometimes point at a different problem than what the crash analysis engine pointed at. So let me do that bang analyze -v. And this should be faster, and there we go. And it's pointing at, by the way, this image here as the problem, this IBM MP driver. And the reason it's picking that is it looked at this stack trace, and here's the call debug check. And the way this works is that function called that function, this function called that function, and so on. So MI system call eventually called kbug check. But what happened is this driver right here, IGD KMD64, kind of set off the chain, and it's a third-party driver on the stack. So which is why the crash dump analysis says, hey, it's probably this guy. And if you click on that, you can see a timestamp. So that's the next thing you do is, let's see how old this thing is. In this case, this dump was from about 9 months ago. You can see this is from 2015. So this image is 2 years old, almost certainly something newer. And so what I went to Lenovo site because this was a ThinkPad that I'm on, and checked for updated drivers. And sure enough, there was an updated image driver. I installed it, and after I installed it and rebooted, I was able to run PowerPoint without any problems. So just opening that dump, seeing the name of the image, going into the Lenovo website, I knew that that was a graphics driver I could see from the description and for the Intel integrated graphics chip, and I was able to go and get a fix, and my system went on its way. Again, PowerPoint crashing, fixed it, resolved it to a graphics driver. So that's basically how easy it is. So even a few minutes, and it's not always that straightforward, but a few minutes is worth it because you might be able to get your systems working again. So that brings me to the conclusion of the talk. I just wanted to show you some evolutions in the Windows 10 blue screen that we've got coming. One of them is that we're adding QR codes we're trying to push a lot of people to the Windows Store. So QR code will give you some free credits to compensate you. And then we're also trying to get a lot of people to use Cortana. So we figured one of the ways to promote that was, and I'm just kidding, those are both not real. So that brings me to the conclusion of the talk. I hope you found it interesting and useful and walk away with a few tips, some of the features and the tools that maybe you weren't aware of. I showed you, like I said, some things that I haven't shown really in previous cases that I explained. So even if you've been to ones before, hopefully you got something new out of this. If you have a case that you come across, please email it to me with screenshots and the log files so I can add it and share it with other people. And then finally, one more time, 1, 2, 3, keep calm and run Procmon. And if you want a t-shirt that says that, there's the URL right there. Chris Jackson had those t-shirts made, so go get one and be the coolest kid at your company. With that, thank you very much and have a great Ignite.